Hello, I'm Susan from Ohio Energy Project. Think about how often the weather changes every day. It could be cool in the morning, rain in the afternoon, and then steamy hot in the evening. Are there patterns to the weather? What's the difference between weather and climate? Has it changed over the last 100 years? The terms climate change and global warming seem to be all over the news. What exactly do those terms mean? Are there effects happening here? Let's get the scoop by reading the book Global Warming. This book, Global Warming, was written by Shelley Buchanan as part of the teacher created materials. It's getting warmer. Earth is warming up. Most of this warming has happened over thousands of years, but things have sped up over the last 100 years. Earth's average temperature has risen 1 full degree. That might not sound like much, but it can affect Earth's oceans, land, plants, and animals. This change is known as global warming. But to understand the process, there are a few things we must look at first: climate and weather, the carbon cycle, and the greenhouse effect. Little Ice Age. Earth naturally goes through gradual warming and cooling periods. Between 1300 and 1870, Earth experienced a cooling period known as the Little Ice Age. During this time, average temperature dropped and the world got a little colder. Weather versus climate. Weather is the outdoor conditions of a place on one day. Weather can change in just a few hours. Weather forecasters tell the possible temperature and cloud cover for a place at different times. Climate is the average weather for an area or region over time. For example, Montana has a snowy climate. Hawaii is known for tropical climate. Put simply, the difference between weather and climate is time. Look at the chart that's on the bottom of page 5 and notice the trend of the temperatures from 1860 to the year 2000. The carbon cycle. Every living thing on Earth is made partly of carbon. Carbon moves through the atmosphere, land, and oceans. It's always on the move. Carbon joins with oxygen to make carbon dioxide in the air and water. Plants on land and in the ocean absorb this gas to make food. Animals breathe in oxygen and breathe out carbon dioxide. Forest fires and erupting volcanoes release carbon dioxide too. Fuels are extracted from the earth. Carbon is released into the air by burning of fossil fuels and from the forest. Plants absorb carbon dioxide. Animals exhale carbon dioxide. When animals and plants die, carbon moves again. It rejoins the air as gas given off from animal decay. The carbon dioxide that does not move to the air goes into the ground. Dead plants and animals decay and compress over time. Some of this carbon turns into fossil fuels. Most of the Earth's carbon is found inside rocks and fossil fuels. Moving carbon out of these materials into the air is usually slow. It's a perfect balance for our planet. When people burn fossil fuels such as coal, natural gas, and oil to create power, carbon quickly moves into the atmosphere. This rapid release upsets the carbon cycle. Scientists estimate that between 2000 and 2010, the world added about 100 billion tons of carbon to the atmosphere. Carbon has many uses. In its diamond form, carbon is used for drilling and cutting. Other things made of carbon include graphite in pencils, lubricants for machinery, and charcoal. The greenhouse effect. One reason Earth is heating up is the greenhouse effect. This is a process that happens in nature. Carbon dioxide in the atmosphere traps the sun's heat in a way that's similar to a garden greenhouse. A greenhouse has a clear roof and walls. Sunlight enters and the sun's warmth gets trapped. This makes the air inside the greenhouse warmer than the air outside. Plants thrive in this warmth. Earth's atmosphere acts like the roof and the walls of a greenhouse. The sun's rays stream through the atmosphere. They warm the ground. Greenhouse gases in the atmosphere allow some, but not all, heat to escape. It's a good thing this happens. Otherwise, we would have temperatures similar to the moon. There, it can reach to boiling 123 degrees Celsius, 253 degrees Fahrenheit during a day, and a frigid negative 153 degrees Celsius, negative 243 degrees Fahrenheit at night. We would not be able to survive without some greenhouse effect. Ozone layer. In 1985, scientists discovered that the ozone layer was decreasing in thickness. The ozone layer is part of the atmosphere that protects us from the sun's radiation. People were encouraged to stop using aerosol sprays such as spray paint and certain hairsprays. This helped the ozone layer thicken again. Now, new research has some scientists worried that a thicker ozone layer may actually speed up the greenhouse effect. Lately, scientists have seen an increased greenhouse effect. If it gets too strong, then too much heat will get trapped in the atmosphere. This could make the Earth's temperature rise. Many think that humans are to blame. Causes of global warming. There are many reasons the Earth is getting warmer. Global warming is a natural process, but there is a great deal of evidence that suggests humans are speeding up the process at an unsafe rate. Burning fossil fuels, deforestation, and farming all speed it along. Burning fossil fuels. People started burning large amounts of fuel over 100 years ago. This was the height of the Industrial Revolution. People built factories and machines. They made goods faster and cheaper than before. Huge amounts of fossil fuels were burned to make these goods. People around the world wanted to buy these cheaper products. There was a boom in building roads and transportation. This meant using even more fuel. Then along came the automobile and the light bulb. Electric power plants popped up around the world. These plants burned fossil fuels to create electricity. Advances like these changed the world, but burning fossil fuels released more greenhouse gases into the air. Today, we use more fossil fuels than ever before. This may be causing the greenhouse effect to rise out of control. There is 30% more carbon dioxide in the air today than there was 150 years ago. On page 11, this graph and map shows the countries that release the most amount of carbon dioxide, and the graph shows how it has risen from 1900 to 2010. Deforestation. Trees are an important part of the carbon cycle. They help take carbon dioxide out of the atmosphere and replace it with oxygen for us to breathe. They also change it back to carbon in the soil. Trees do this all over the world. With more than 7 billion people living on Earth, lumber is in great demand. People are chopping down forests at a rapid rate. The trees are used to build houses, furniture, and other goods. When whole forests are chopped down, it is called deforestation. These trees could help absorb excess carbon dioxide. Now we have more carbon dioxide in the air and fewer trees to remove it. Please note the picture on page 12 that shows how much remaining lost and destroyed rainforest we have in the Americas. Farming. With more people on Earth, there are more people to feed. There is a greater need for farms. Believe it or not, the methane gas expelled by cattle and other farm animals is another greenhouse gas. Fertilizers used to help crops grow can produce a different greenhouse gas, nitrous oxide. All of these factors contribute to global warming. Although they are not the only causes of the problem, they make it more difficult for Earth to release excess heat. More on deforestation. About 80% of the world's species of animals are found in tropical rainforests. As rainforests are removed, some of the animals die from habitat loss. Without tree roots to hold the soil in place, much of the nutrient-rich topsoil is washed away. Landslides also become more common. Effects of global warming. You may be thinking, so what if the world is a little warmer? Maybe you like warmer weather. Well, it's not just about the weather. Global warming could change the whole world's climate, and this could have tragic effects. Extreme weather. Earth's rising temperatures are stirring up extreme weather. In some places, rain is falling harder and faster. In other places, there is less snow and more rain. Global warming is bringing both floods and drought. Rising temperatures also create warmer waters. This means more evaporation. It means extra moisture in the air. With more moisture comes more rain. Stronger hurricanes are hitting many coastlines. A hurricane can quickly climb to intense levels. This is what happened along the Gulf Coast in 2005. Hurricane Katrina started as a Category 1 hurricane. It quickly turned into a Category 5 storm. This took just 4 days. Winds whipped to 280 kilometers per hour, or 174 miles per hour. Waves rose 5 meters, or 18 feet high. Many homes and buildings were destroyed. Most trees were uprooted. Hurricane Katrina caused billions of dollars in damages. People were left without homes. Extreme storms are becoming more common around the world. Lightning strikes are expected to increase 50% over the 21st century due to increased water in the air. Hurricane categories. Hurricanes can be ranked using the Saffir-Simpson hurricane scale. The scale is split into categories. It starts at 1 for minimal damage and goes to 5 for significant damage. This scale also includes wind speed and the damage caused for each category. Check out the chart on page 15. Melting messes. It's always sad when ice cream melts before it can be enjoyed on a hot day. The polar ice caps in other icy regions melt just like ice cream as Earth heats up. In Alaska, 85% of the state's land is permafrost, or permanently frozen land. But in some places, permafrost is beginning to melt. There are cities, towns, roads, and bridges built on this frozen land. When the permafrost melts, it causes the ground to shift. Bridges and roads collapse. Buildings tilt and shift. Trees and even whole sections of forest slump down. These problems cost millions of dollars to fix. Increasing temperatures also impact the world's largest ice formations. Glaciers are melting at record speeds. Recent reports show that these ice masses are shrinking. They are losing billions of tons of ice every year. Ice caps near the North and South poles are shrinking at a shocking rate too. The Arctic sea ice is the smallest it's ever been. Many problems are predicted if this melting continues. Winters are getting shorter. Spring-like temperatures come 10 to 14 days earlier than they did 20 years ago. I'm melting. Arctic ice caps are losing about 9% of their area every 10 years. If this continues, the Arctic will have no ice during the summer by the end of this century. This means that sea levels will rise. And since ice reflects the sun's energy back into space, this also means that the Earth will absorb more of the sun's energy. Disappearing acts. With changing climates, many plants and animals find themselves unfit for their current environments. It takes many years for a species to adapt. Sudden changes can make it hard for plants and animals to adjust. Some say that by 2050, 1 million species of plants and animals may disappear. This would be due to an increase in carbon dioxide and other greenhouse gases. Scientists around the world agree with this prediction. The loss of these living things will impact other forms of life on Earth. Animals that depend on these life forms will need to find other food or homes. If they don't find what they need, they will die off. For example, shrinking Arctic ice limits land and food for polar bears. Polar bears are used to living and hunting in large frozen landscapes. With a shrinking environment, they don't have the space they need. They are struggling to survive. Polar bear population. The polar bear was added to the Endangered Species Act in 2008. It is officially a threatened species. Scientists think more than half of the population may be gone by 2050. The reduction of icy landscapes is a problem for seals too. These marine mammals rely on icy formations to make homes. There is little area left for seals to live and breed. In 2007, the golden toad species became extinct. Many scientists think it is because extreme weather patterns dried up the toad's habitat. Food is a must. Polar bears are forced to swim longer distances to find prey. With less ice for them to stand on during these long swims, it increases their risk of drowning. Polar bears have recently been documented to swim more than 48 kilometers or 30 miles to follow a food source. The shrinking of ice in Antarctica is also a problem for many plants and animals such as penguins, phytoplankton, and seabirds. Less ice makes it hard for penguins to live and care for their young. Adult penguins must travel all day in search of food. This leaves their young alone to fend for themselves. Young penguins become open prey to their natural predators. As a result, some penguin populations are shrinking. Phytoplankton are dying too. These microscopic organisms serve as the start of many ocean food chains. Both tiny krill and huge whales feast on phytoplankton, but they cannot live in warming waters. The phytoplankton populations has shrunk more than 40% in the past 65 years. Other species are struggling because of this food loss. More than half of seabird species have dropping populations. Seabirds eat fish that eat phytoplankton. Seabirds cannot find enough fish to eat. When plants and animals become endangered or go extinct, it is felt throughout their food chains. Food chain reaction. Krill are tiny shrimp-like creatures that swim in massive groups. As the phytoplankton population has plummeted, so has the krill population. Since 1970, they have decreased by about 80%. These krill were caught by people and will be used in products such as vitamins, fish bait, and food. Penguin problems. Penguin ships are often swept out to open ocean due to thinner ice. The amount of adult penguins that are able to reproduce has split in half in less than 20 years. Over time, if temperatures continue to rise, the number of penguins will continue to decline. Problems for people. As sea ice melts, sea levels rise. Rising waters are a threat to coastlines. Many of the world's largest cities are built on coastlines. They were originally built near the water for access to trade routes and travel. If melting continues, people may have to move from coastal communities. There will be no way to hold back the rising ocean waters from these man-made places. Global warming is also causing changes in the atmosphere. In some areas, changing temperatures are causing more storms and floods. Other areas are getting hotter and drier. There, hot air streams are pushing down on the ground and the ocean. This makes it harder for cooler air streams to come inland from the sea. Heat waves are growing in number and lengths. Some heat waves are lasting for weeks. This causes hardships for plants and animals as well. Overexposed animals and people fall ill and die of heat exhaustion. These extreme temperatures can also lead to devastating droughts and epic wildfires. Predicting plant outcomes. Some scientists predict that extra carbon dioxide in the atmosphere will initially help plants grow. After about a year, the effect will slow down and then stop entirely. Plants would be pushed out to make room for other plants that are adapted to warmer weather but are less productive. Temperatures in Death Valley, California reached a scorching 54 degrees Celsius or 129 degrees Fahrenheit in July of 2013. Changing coastlines. Some studies show that if all of the ice melted during global warming, new coastlines would form. In North America alone, Florida and the whole East Coast would disappear. San Francisco would become a cluster of islands, while Southern California would mainly be underwater. Making an impact. There are things people can do to slow global warming. In fact, many countries are starting to use renewable energy. It is much better for Earth. This energy is not made from fossil fuels. It is thought of as being clean because it does not put out more greenhouse gases into the air. Wind power is one type of this energy. One wind turbine can power 1,000 homes. Solar power is also a great choice. Solar panels use the sun to power just about anything from cell phones to cars. Hydropower is also a clean option. It uses moving water to make electricity. Scientists are working to create even more clean energy sources. But this doesn't mean that the rest of us can't help. Together, we can help cool the planet by reducing our carbon footprints. Think of all the ways that you can save energy. Put on a sweatshirt instead of turning on the heater at home. Use energy-efficient light bulbs. Recycle. Recycling can save about 450 kilograms or 990 pounds of carbon dioxide a year from entering the atmosphere. If everyone follows these simple steps, we can continue to move in the right direction. The future of fuel is looking green. People often use the term green to say something is environmentally friendly. Think about it. Scientists hope to reduce carbon emissions by using iron fertilization. They want to feed iron to algae to make them grow faster. Then there would be more algae to absorb carbon dioxide in the atmosphere. Carbon storage. Scientists are studying ways to contain carbon dioxide emissions as they leave factories by burying them deep underground in old oil fields. By burying emissions underground, there is less carbon dioxide in the atmosphere. Public transportation can also cut carbon dioxide output. Ride a subway, a bus, or a train instead of driving a car. Then there will be fewer cars on the road and less carbon dioxide in the atmosphere. Carbon footprints can be reduced even further if people walk or ride bikes. Factories use a lot of fossil fuels to make the things you buy. Some people are trying to use less of these goods. By using fewer goods, factories end up making less and less fossil fuels are burned in the process. Some people are making things at home instead. Others are buying used goods. Some people are even choosing to buy things from companies that have environmentally friendly ways of making goods. Buses, trains, and subways are types of public transportation. You can also reduce your carbon footprint when you're finished with a product. Many types of packaging can be recycled. The more we recycle and reuse things, the fewer new things have to be made and the fewer greenhouse gases will be released into the atmosphere. This can help cool Earth and bring it back into balance. If we all work together, we can make a difference. Driving hybrid or fuel-efficient cars can help lower greenhouse gas emissions because they use less fuel and produce fewer greenhouse gases. Ethanol for engines. The cars that race in the Indianapolis 500 are now using ethanol fuel. This fuel is made from plants such as corn, trees, and grasses. A race car using ethanol goes faster and is also better for the environment. Win-win. So, now that we've finished reading the global warming book, what did we learn? We learned the difference between weather and climate change. We learned about the carbon cycle and the greenhouse effect. We learned the causes of global warming include the burning of fossil fuels, releasing more carbon dioxide and other greenhouse gases into the atmosphere, while deforestation removes the plants that can remove that carbon dioxide during the process of photosynthesis. We also learned that the effects of global warming include extreme weather, sea level rising, and loss of species due to heat and food chain interruption. For people, problems include heat waves, droughts, storms, and problems with our agriculture. But we also learn that we can be part of the solution. Encourage the use of renewable energy. Be energy efficient. Use public transportation, recycle, and use less stuff. Reduce your carbon footprint and encourage others to do the same. Do more research and learn about global climate change because little things add up. Thanks for watching.